Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. This is episode 151.875. It's a KubeCon live recording, live in person here at the event, as
Yep.
you can see. The topic is about taming Kubernetes access control, and our esteemed guest is Lukas Kaldstrom, who just gave us a talk on this great topic, very successful, well-attended talk. So Lukas, welcome.
Yeah, thank you.
So before we dive into the talk, maybe just a quick intro. You're working on your master's thesis, and how'd you get pulled into this topic?
Yeah. So, well, the story goes kind of long back already. I started with Kubernetes, contributing and you know being part of the ecosystem already some 10 years ago, and Kubernetes is 11 or around. So been here for a while, and yeah, I'm well. Back then I was in high school. These days I'm doing my master's. Um, so that's all exciting, being able to contribute to the cloud native ecosystem in many ways, like running meetups and leading different groups within the community and so on and so forth. At the moment, I'm focused on access control, taming some of the long-standing issues that we've had, or areas of improvement, like stuff is already good but could always be better. So this is one of those areas, and yeah, it's now the master's thesis was basically an opportunity to take some time to go deep into an area of unsolved problems and propose some solutions. And yeah, that's what we just presented. And yeah, I'm a staff software engineer at Upbound, the control plane company.
You reminded me that 5 years ago I was seeing ads that said 10 years of Kubernetes experience required,
Yes.
and it wasn't possible. But now
Now it
it
is.
is.
Yes,
Yeah,
yes.
finally.
I checked that now. Finally, yes.
Um, And you started your presentation and you were talking about some of the existing RBAC functionality,
Mm.
which I was talking to one of the audience members later from who was formerly at Red Hat, and he said Red Hat pushed a lot of those original RBAC um, um, features. But maybe you could talk about like what's there, what can you do with RBAC, and what are some of the limitations of RBAC?
Yeah. So the person I think you're referring to, Jordan, is one of
Yeah.
the most experienced and renowned Kubernetes maintainers. So yeah, also one of the leaders of the SIG auth group, which this kind of all falls into. And yeah, Kubernetes RBAC, we got it into Kubernetes kind of as a first access control, or like the major access control mechanism in 2017, if I recall correctly. And it's basically a way to define. You can define a role. In the role, you kind of say that these types of different objects should, be selected by this role, and anyone that's bound to this role should get certain privileges. For example, read and write access, or some even more fine-grained as well, to the different resources that are in a Kubernetes cluster.
I don't remember if it was you or Micah who presented the RBAC. I think was it Micah who presented the RBAC, or did
Yes,
you present?
or
Yeah.
well, yeah, yeah.
But
Was
he mentioned that there is a weird combination of ors and ands when you have multiple, let's say, policies that apply, RBAC policies that might apply to a certain situation. And I was a little confused by that. But are you familiar with like how that gets sorted out, and what were the limitations of that?
I don't think it's weird in any way. It's just like, if you have multiple roles, then and each role gives you some privilege, right?
Hmm.
Then it's logically an or between those roles, right? So I think that's probably
But
fine. Yeah.
yeah, he mentioned that but there's also some of the other conditions get anded, maybe within I
Right. Okay.
guess.
Okay. So you can say that, well, there's lots of different. So you can have, for example, one trust domain in Kubernetes, inside of a Kubernetes cluster is a namespace, right? and you can say that well, you can list all of the workloads within this namespace, and this serves as a kind of logical isolation boundary, right? And that's then, but then you can also scope it down to say that, well, within this namespace and this certain name of a resource, only these certain names, you should have access to. So that's basically the and maybe
like a
maybe it
filter
was,
almost.
yeah, like maybe it was a confusing presentation, but like that overview of it. But that's basically the idea that, well,
yeah.
you can say that, well, you can say anything within this namespace, or you can say just this resource within this namespace, or just this resource and this name within this namespace.
Yeah.
So you can go pretty fine grained in that sense, to lock down to exact the thing you want.
You're right. I think I got lost there, and then so I was like, okay, I'm confused, so it must be confusing.
Right. Yeah. No,
but
it's
I wasn't staring at the docs either.
No, it wasn't. It's not that confusing, I think.
Yeah.
In that sense, yeah.
You
have a role. That role gives you some privileges, right?
Yeah. And if you have if any one of the roles you have satisfies
Yes.
that, then you're good to go.
Yes.
Yeah. And so what's been the evolution of this? Why wasn't that enough? And what comes after that? Like, how do we get more flexibility to express different kinds of policies?
Right. So Kubernetes, I think really the main innovation in Kubernetes is API machinery, or that's one of the main innovations in Kubernetes, is that it presents you with a unified API layer, and where all resources are kind of at the same hierarchy, right? So like you have workloads, you have secrets, you have all kinds of other kind of resources you can operate on, and you can also make your own, like register your own custom types within there. So if you want to add, a database type, that logically represents some database somewhere, you can register that. You can tell what should the fields be, and that's, so it's super extensible, the whole system, and that really makes Kubernetes good for being this kind of generic control plane on top of which you manage basically everything else, right? And that gives you the power. So RBAC gives you the power to kind of lock, like give, for example, you access to, okay, you can create a database, right? If we have such a type, or you can create a workload, or maybe you can list some secrets. That's the level of granularity that you get, and especially within these namespaces, which is a kind of logical isolation boundary within one Kubernetes cluster.
So at the end of the presentation, you were asking for comments on a certain proposal for, I think, conditional access.
Yes.
And is that part of the new framework you were just describing, or and what's the how long is that sort of, I want to call it an RFC, but
it's an RFC.
Yeah. How long has it been around, and what do you think? What has the community reacted to it?
Yeah, I think it's been interesting and good feedback. The gist of it is basically that, well, the existing Kubernetes authorization, it's already pretty expressive. It doesn't go into the objects very well. So I can tell you that, well, you can create a storage, a volume, but maybe if you don't, or well, if you're the, let's have you as the admin, and you give me policies, right? You say that, well, Lukas should be able to create volumes, but he shouldn't be able to use more than 100 gigabytes or something like that for a single volume. Or maybe Lukas should only be able to use less expensive hard drives in the system. So when I create those, I cannot use the like super fancy things, right? That are expensive. This type of conditional policy was it was technically possible in some scenarios before, but it wasn't as neatly integrated. So now the proposal is basically, well, you can give this policy that not only says what type of resource can I like create and where, but also what contents of that resource should we have. So in that case, like going into there and saying, yeah, just 100 gigs, that's all you get.
Right. Looking at not just the metadata around the
Yeah.
request, but actually seeing what's in that request.
Yeah.
And there was options, so it wasn't just Cedar that you could use. You could use also, I think I saw OPA and Cell maybe.
Yeah. So like the proposal for how to implement this in Kubernetes as a baseline is abstract in the sense that it doesn't, it works with anything that can do partial evaluation basically.
Mm-hmm.
And as long as you have a system that can do partial evaluation, which we can talk about in a second if you like, that can like basically find these conditions and enforce them later.
Yeah. Actually, so people who want to watch the video, I believe all of these are videoed, all of these sessions.
Yep.
So audience, you can go and watch the video session in detail.
Absolutely.
But why is partial evaluation here so important for getting to conditional evaluation?
Yeah, so it's a good question. Well, an API server like Kubernetes, again, it's a generic API server. You can think of it as basically any REST API, right? But that is extensible, and you can register your own types into, and they get stored in a consistent database, and so on and so forth. Now this API server is often like exposed to the whole internet, right? It can be. Sometimes maybe it shouldn't. Sometimes maybe it should, right? Anyways, especially if it's not, regardless of if it's exposed to the whole internet or not, you don't want malicious people to send big payloads and try to DOS your API server, right? That's bad. So like if you have someone malicious that starts DOSing you, the worst thing you could do is start deserializing that. They send some random big JSON file, right? And you start eating memory and looking at that just to kind of find out that, well, this is garbage, right? And how do you prevent against that type of denial of service attack? Well, one way to do it is that you run authorization. You look at, okay, so we have a user. The user is trying to perform a certain request, right? This is only metadata at this point. And now we figure out that is it possible for this user to become authorized, right? Does this user stand a chance of being successful with this request? And the way to find that out is through partial evaluation. So if you have a policy like the one we had in the example, Lukas can create storage with the inexpensive class, the cheap class. Now if I'm then trying to create a storage volume, then, well, the first predicate will be, is the user Lukas? Yes. So that's good. And then it's an and then it says, is it a create storage volume? Yeah, that's also true. The third condition is that, well, does the storage object, is a storage object of like HD class, right? That we don't know actually, right? Because we didn't at this point we didn't deserialize the object because we don't know is this Lukas guy any good or not, right? So that but if we got this far, then actually we can say that, well, there's a chance, this request stands a chance of getting authorized because there was clearly someone that had an intent to give Lukas some privileges, right?
Yeah.
And the condition then that like is purely on the object. So now, well, we gotta deserialize the object to look at it, and that's fine. And so that's what happened next. Then we deserialize the object, and then we look at the condition again. Well, did I conform to the policy or not? Well, either then it's allowed or denied, right? But now consider a random attacker on the internet, right? They send a request. They also try to create a storage volume, but they don't have any policy that apply to them. So you can directly see that, well, is user Lukas will return false. And false combined with an and is always, whatever the rest of the things are, it's always going to be false.
Right. It reminds me a little bit of query optimization in the database. But yeah, I could see that. And so I wonder, how does that actually work in Kubernetes? Because the policy is sort of one chunk, and you said there's this part at the end. Is it that the conditional evaluation gets provided separately or in some with some container around it, so we know this is the first part that you validate, and then this is the second part?
No, that's the neat thing with, for example, I mean, you can do it in both ways, but the neat thing about this proposal and this method of using partial evaluation is you don't need to segregate these things. I mean, now here, this new feature is so abstract that like it can support any front end. You can expose this, like you can have a GUI to, web UI to kind of, have them connect different things to make the policy, or have them write it in JSON or whatever. It's like, I don't kind of like dictate how you do it, right? But I don't force you to split them. You can split you can put all of the conditions in the same, like all of the predicates, all of the policy in the same place, and then thanks to for example CDAR's typed partial evaluation, this works no matter in which order everything is kind of set. So that's a neat thing. Yeah, it doesn't matter. Yeah.
Another feature I heard about, which sounds a little similar, but I think it's different, is DRA, dynamic resource allocation, where let's say I want to let maybe a process use a GPU, but I don't want it to use all my GPUs.
Yes.
And it's not quite a security policy. It's sort of somewhere.
No.
What are your thoughts about that? Could you use Cedar to express those types of not security policies, but maybe limits?
Yeah. So especially on a per object limit, yes. Because well, in this case, the relevant API is called resource claim, and a resource claim is something that normal users should be able to create, because normal users, especially as AI is so hot these days, should want to use a GPU in many cases legitimately, right? But they should not be able to take over the whole GPU. And that's where the condition comes in again, that like you can give a user, Lukas, like me, ability to create this resource claim, but only as long as this boolean in this object is false, like admin access, and I shouldn't have that.
Right. In the resource example, it seems like it could get a little complicated, because I would imagine that like, can this user use a GPU? Yes, but what's the total number of GPUs in effect? Because there's a cluster and maybe 5 of them are concurrent, and what's the current state? It seems like something I'd want to put in the context of the request to make my policy.
Right.
But then the question is, how would we get that into the context?
Yeah. So that is not then. Yeah, if we kind of move on to quota, that's another API in Kubernetes for quota, right? So this is kind of this authorization layer. You should only put what is kind of authorization sensitive, like security sensitive, in there, and then deal with the quota kind of limits and issues with another API, which is called resource quota.
Right. It reminds me also of, there's user preferences and there's security policies.
Yep.
And sometimes they seem related. So it reminds me of that too.
Yeah. The boundary is not like totally clear sometimes on where it goes, but at least this gives the admin the possibility to decide what's best in their case.
What are any news in Cedar? I know Cedar was recently accepted to CNCF
as
a sandbox project. I think I saw Micah announce that. I posted a slide about that. Any thoughts about Cedar news, or anything you're excited about in Cedarland?
Yeah. Well, Cedar is a great project, and in this in our talk, I put up I created a demo some month ago, where basically I said that this feature in Kubernetes, it's agnostic to whatever you use. Is it Cell, OPA, whatever? I made an interface, or an implementation of it using Cedar, and that was very neat. I'm quite happy with the result, and this makes it possible that you can now, like, using the Cedar language, express these policies for Kubernetes, right? And you can express them in ways that you couldn't do in way more expressive, kind of make more expressive policies than you could before using the Kubernetes built-in features. So that's exciting in many ways. So like, for example, there are secrets in Kubernetes, right? There's a secret type, and this is basically just a JSON object in which you store some data, right? That is considered secret, right? But it's stored. You can retrieve it from the API in plain text. So it's not in that sense like decrypted or hidden. It's just a key value store, right? Now, if you have many of these secrets, you probably are pretty interested in like locking down the access to these secrets, right? If you put a TLS key or something in there, it shouldn't be retrievable by anyone, really, for obvious reasons. So now with Kubernetes, before you could say that, well, Lukas has access to only this secret, right? But the existing methodologies are allow only based. So it makes it hard to actually make sure that no one actually else than me, gets access to this my own secrets, right? And that CEDAR helps with, for example, this. So, or you could say that, well, if you're a load balancer, at the edge of the internet, you need access to some TLS keys, right? Necessarily to decrypt traffic, for example.
Yeah, authorization policies around secrets seems like a pretty natural
it's a
application.
And today you just have to say that, well, the load balancer on the edge of the internet, it has access, but maybe it doesn't know the names of what it has access to, right? So what is then the predicate that it should kind of select based on? Well, secrets have a type, so you could say that, well, it has access to all the TLS secrets. So that's a fair enough distinction, but you couldn't express this like read just with type secrets. Before these, there's two new kind of enhancement RFCs or enhancement Kubernetes. One that is already in beta or GA, so general availability, or and then this that I'm working on at the moment. So this kind of with CEDAR, we are able to express this, and actually to make this possible, we actually use CEDAR analysis as well.
Right. And my last question. So these policies, you could probably express them in OPA or CEL. What's the advantage of CEDAR over CEL or OPA, you think?
Yeah, so I think that the analysis part is really compelling, right? So for those that don't know, CEDAR supports checking, like, if you have a policy, and for example refactor it, is it still the same policy? Like, does it behave the same, give the same allow or deny result for every single possible request and object you could make? So that's like really big space, and if you just write unit tests by hand, that's going to be a lot of corner cases that are really hard to see. But CEDAR, thanks to being kind of limiting the expressiveness, they are actually able to prove that, well, this policy before and the one you refactor after are the same, right? And that's really powerful. And in our case, we if you do a read and with this CEDAR authorizer, it will check that whatever. So you have selectors, you can select on kind of different attributes that the objects have, right? So you can say that list secrets, but only if they have type TLS, right? So that's kind of one example of a predicate. And what the authorizer will do, thanks to CEDAR analysis, is that it will say that, well, you have this set of selected objects. So you have an expression of the selected objects. And whenever an object is selected, it has to be also authorized. And that you can do for every, you can enforce that for every object, right? And that's interesting because for every object, we don't know what's in the database. So technically, for every object, it means that, like, well, there's an infinite amount of possible objects that could exist. Like there are like so many strings, and similar. How do you actually check that it's that is the case? How do you make sure that whatever comes from the database is authorized? Well, you use the negation, and that's a really cool trick. So the equivalent of saying that for every object, whenever it's authorized, whenever it's selected, it also has to be authorized. You ask, is there any object that is selected but not authorized? And if there is no such kind of corner case or edge case, then you know that everything that is returned is safe. So zero analysis lets us do this, which you can't do with the more expressive OPA and cell.
Interesting. Yeah, and it goes beyond linting, for example.
Way beyond linting, yeah.
Yeah.
But linting is also a really good use case. You can check that, does my policy make sense? Well, then maybe it's always false because you kind of put logically inconsistent things.
Awesome. Well, I'm actually going to hear. I've been surprised by the scale of some of these, and I think the analysis starts to make sense as the scale goes up. I'm about to hear a talk from Pinterest where I think they're deploying like 90,000 like workloads or pods a day. And this is where I think those tools become really powerful. But thank you so much, Lukas, for making being a live stream, live in person, guinea pig
in Atlanta,
today.
Yeah.
And thank you, audience. And we'll see you on Tuesday back in the regular